Hello dear friends, welcome to my channel. Today's discussion is nuclear reactions and nuclear bomb. The heavy nuclei size 92 U238 disintegration by their own, resulting into the formation of the nuclei of new elements. Such nuclear disintegration are called natural nuclear transformation. We know that in chemical reaction, the rearrangement of atoms takes place. Similarly, in a nuclear reaction, the rearrangement of nucleus takes place. When the bombarding particle strikes the target nucleus, the natural nuclear transmutation led Rutherford to think that it might be possible to disintegrate atomic nuclei by artificial means. In 1999, he was able to bring about the first artificial transmutation by bombarding nitrogen nuclei with alpha particles, which produced an isotope of oxygen and proton. The reaction taking place may be represented by the equation 7n14 2He4 helium. This is the helium, this is oxygen, and this is proton. The reaction taking place proton. Okay, so such nuclear transmutation carried out by artificial means is called a nuclear reaction. The bombarding particle called projectiles. Okay, after the successful attempt made by Rutherford, many other such nuclear reactions were carried out. The bombarding particle called projectiles generally used alpha particle, proton, neutron, and gamma particle is gamma. So alpha particle is 2He4. 2He4 is called alpha. Proton particle is called 1H1. Sorry, this is the proton. Proton is 1H1. This is writing wrong. Okay, neutron is 0N1, and another is deuteron. Deuteron is 1H2. This led to the formation of more than 500 artificial radioactive isotopes. The nuclear reaction 7N14 2He4 and O8O17 1H1 is referred as alpha proton proton reaction. A few important nuclear reaction are as given by example: alpha particle as projectile, alpha p reactions. You see, this is the alpha, and p proton. Uh, proton is the outcome result, and alpha is input. Okay, reaction. So alpha p reaction. This is the another alpha p reaction. Two reaction. One is Mg 12 Mg 24 2He4 13 Al27 1H1 13 Al27 2He4 Si 30 14 1H1. Alpha neutron reaction. This is the alpha and this is the neutron. So it is alpha neutron reaction. This is lithium and this is the B for barium. And another is, this is the aluminium. Aluminium 0 N1 and Na T23. So proton as projectile, when proton as projectile, then P alpha reaction. This is the P alpha reaction. So boron and hydrogen. Boron has 5 atomic number. We see boron and proton is the alpha. So it is proton alpha reaction. This is the proton alpha reaction. Okay, alpha proton reaction and proton alpha reaction, where proton is as a projectile. And proton neutron. Proton neutron is, this is the proton and neutron. This is the proton neutron reaction. Two reaction I gave. Please write down everything if you want to learn. And proton deuteron. Deuteron is 1H2 is called deuteron. So example, this is the proton deuteron. This is the proton deuteron. This is the proton gamma reaction. So it is gamma and proton reaction. This is the gamma and proton reaction. This is the neutron as a projectile. Neutron alpha reaction. This is neutron alpha reaction and neutron alpha reaction. Neutron proton reaction. Neutron proton reaction is neutron proton reaction. Neutron gamma emission. This is the neutron and gamma is output. Please check every balance. And deuteron as a projectile. So deuteron alpha reaction. So this is the example of deuteron or alpha reaction. Deuteron proton reaction. This is the deuteron and proton reaction. Deuteron and proton reaction. Deuteron neutron reaction. So it is deuteron neutron reactions. And gamma ray photon as projectile. So a nuclear reaction in which gamma ray or photon is the projectile is called photonuclear reaction or photo disintegration. So this two reaction is neutron as a projectile. Gamma as a projectile, sorry, gamma as a projectile. Symbolic representation of nuclear reaction. In a nuclear reaction may be represented by the equation. This is the equation where X, P, Y, O represent as target nucleus, bombarding particle, and residual nucleus and outgoing particle. O for outgoing particle. Nuclear reaction obey the following conservation law. Law of conservation of nucleon number and law of conservation of charge number and law of conservation of mass and energy. According to this law, the energy required to carry out the nuclear reaction or the energy liberated is equal to the energy equivalent of the mass of the nuclei on the two sides of the equation. Law of conservation momenta. The linear momenta of residual nucleus and outgoing particle is always equal to the linear momenta of target nucleus and bombarding particle. Q value of a nuclear reaction. So friends, in a nuclear reaction, sum of masses of the target nucleus X and the bombarding particle P may be greater or less than the sum of the masses of the product nuclei Y and outgoing particle O. To account for the law of conservation of mass energy, the nuclear reaction is represented by X plus P tends to Y plus O plus Q. Here Q is called Q value of the nuclear reaction. If the mass of the product nucleus and outgoing particle is less than the mass of the target nucleus and bombarding particle, then Q value of nuclear reaction will be positive. Such nuclear reaction is called exorgic reaction. And on the other hand, if the mass of the product nucleus and outgoing particle is greater than the mass of the target nucleus and bombarding particle, then Q value of nuclear reaction will be negative. Such a nuclear reaction is called endoenergic reaction. Another is exoergic reaction, endoergic reaction. Nuclear fission. Nuclear fission, the process of splitting of heavy nucleus into two nuclei of nearly comparable masses with liberation of energy, is called nuclear fission. The chain reaction, when 235 U92 nucleus is bombarded with thermal neutron, it splits into Ba 141 and Kr krypton 92 along with the liberation of the neutrons. So barium 141 and krypton 92 along with the liberation of 3 neutrons and an energy 200 MeV per fission reaction. This fission reaction may be represented as 235 92 201 N and 56 151 barium, krypton and neutron. A fission chain reaction may die out because the following reasons. Okay, another factor, the energy Q released was estimated to be 200 MeV per fission, or about 0.9 MeV per nucleon, and is equivalent to the difference in masses of the nuclei before and after the fission. Each of 3 neutrons carries of energy of about 2 MeV. As such, these first neutrons will escape, cannot cause the fission of other U-235 nuclei. In order to utilize them to cause fission, So to cause fission of three other U235 nuclei and so on, they have to be slowed down. Niels Bohr will explain the nuclear fission on the basis of liquid drop model of the nucleus. But I will not discuss this model. I just try to say about this, that liquid drop model. Okay, I will discuss it in my next video, that what is the liquid drop model. So nuclear chain reaction. I want to discuss nuclear chain reaction. When U235 nucleus is bombarded with a thermal neutron, it splits into barium 141 and krypton 92, along with the liberation of 3 neutrons and energy of 200 MeV per fission reaction. So U235-92 neutron projectile neutron and barium 56 141 krypton and neutron and plus q. The energy liberated per fission reaction is very large. In each fission reaction, 3 more neutrons are produced. The 3 neutrons may then cause the fission of 3 other U235 nuclei, producing 9 neutrons, and so on. Due to multiplication of neutrons in this manner, the whole of the U235 block may undergo fission in very short time. Such a fission reaction is called uncontrolled chain reaction. So friends, uncontrolled chain reaction is also called nuclear bomb. Nuclear bomb is uncontrolled chain reaction. It is also called so because of the reason that once the fission reaction gets initiated, then it proceeds at such a fast pace that it cannot be shut off. An atom bomb is an example of an uncontrolled fission reaction. A fission chain reaction may die out about of the following reason. To achieve a controlled chain reaction, arrangement is made for the partial absorption of neutrons available from each U235 fission. The controlled chain reaction, in which one neutron is absorbed out of the 3 neutrons from one U235 fission. The neutrons are served by using cadmium rods, which acts as control rods. So control rods are cadmium rods. The system in which the nuclear chain reaction may proceed in a controlled manner is called nuclear reactor. So a fission chain reaction may die out because the following reason: the energy of the thermal neutrons required for the fission of U235 nuclei is of the order of 0.025 eV, and however the neutrons produced in the fission U235 possesses quite large energy as compared to the energy of the thermal neutrons. The neutrons produced in the U235 block leak from the block if the size of the block is smaller than the critical size. Friends, in here, as such a neutrons escape U-235 block without causing the fission of U-235 nuclei, and due to this, the fission reaction may come up to a stop. So that the fission reaction does not stop, the neutrons produced in a fission of U-235 nucleus are slowed down by using graphite rods or heavy water. Such substances are rich in hydrogen nuclei. When fast moving neutrons collide against them, neutrons almost come to rest. Such substances used for slowing down the neutrons are called moderator. And the neutrons produced in the U-235 block leak from the block if the size of the block is smaller than the critical size. The U-235 block is said to be critical size if the number of neutrons lost per second is just equal to the number of neutrons produced per second in the block. The mass of the U-235 block critical size is called critical mass. Some neutrons are also lost due to their absorption by the impurities present in the U-235 block. So that the fission reaction proceeds smoothly, the number of neutrons produced per second should be greater than the number of neutrons lost per second from the block. It is achieved by having U-235 block of size bigger than the critical size. The loss of neutrons from the U-235 block is also minimized by providing a layer of non-fissionable material over U-235 block. In fact, whether a chain reaction will remain steady or accelerate or retard is determined by a factor called neutron reproduction factor. Neutron reproduction factor is defined as the ratio of the rate of production of neutrons to the rate of lost neutrons. Thus, K equals to rate of productions of neutron, rate of loss of neutrons. This is the chain rule. Okay, first generation and second generation and third generation. And here you see the nuclear loss and nucleon gains. Nuclear holocaust. Atom bomb. What is atom bomb? Atom bomb is uncontrolled nuclear chain reaction. Uncontrolled chain reaction is called atom bomb. The energy released on the fission of U-235 is about 200 MeV, is 201.5 into 10 to the power minus 23 joule, equals to 4 into 10 to the power 15 joule, which is equals to, Q value is equals to 20,000 tons TNT. The simple comparison reveals that nuclear fission is a great source of energy, and if 50 kg U-235 is made undergo fission, it will result in a super explosion. In fact, in 1945, USA dropped a atom bomb, fission bomb, on Hiroshima, Japan, which produced an explosion equivalent to 20,000 tons of TNT. The radioactive fallout immediately engulfed 10 kilometers square of the city, and more than 67% structures of the city was destroyed, and about 135,000 people were either killed or injured. The fission bombs are still more devastating. A super explosion of 10 to the power 7 tons of TNT was tested in 1954 by causing the fusion deuterium and tritium isotopes of hydrogen. It's estimated that superpowers powers have so much nuclear weapons in their store which are sufficient to destroy several times the every type of life on the earth. And such a nuclear holocaust will not only destroy the existing life, but radioactive fallout all on this account will render the earth unfit for life for all times. Thanks for watching, friends. I hope I can clear this total concept, but now I will discuss the atomic energy establishment in India. Please check here. Here you can get a lot of atomic energies and examples. Example atomic energy. Example Kota, Tarapuru, Pura, Tarapur, Kolapakkam, and Narora. And I have already told that the deuterium heavy water also used and moderator, that's Kota. Bhabha Atomic Research Center, Apsara reactor at Bhabha used water as moderator. So friends, this is the total discussions. I hope you can clear and understand, and very large and lengthy discussions. So thanks for watching. I think I can give some idea about the nuclear chain reactions for every kind of students, and I hope everyone can understand that what is the importance of nuclear fission, and what is atom bomb, and what is the nuclear fission. Thanks for watching.